This video demonstration is another example of multiplying radical expressions that have a different index. Remember, the index is the number that's in the crook of the radical sign. We call it the crook of the arm there. Lots of ways to do these. So I'm just going to show you one way. It's like writing my own essay. And I try to break it down a lot. So there are faster, more efficient ways to do this, but it doesn't make any difference as long as I apply my rules correctly. So this is what I'm going to do first. I'm going to split this radical up into two different radicals. I'm going to say the cube root of x plus 2 over the cube root of 8. I can do that because I have a fraction under here, and I can, as long as they're the same, I can split them up into their own radical signs. Do the same thing with this one. I'm going to have the fourth root of 16 over the fourth root of x plus 2. The reason I'm doing that is because I'm now going to take the 8 and the 16 and rewrite them as exponents. So again, just taking one thing at a time, I'm going to say the cube root of x plus 2 over the cube root of 2 cubed. With this part up here, the fourth root of 2 to the fourth over the fourth root of x plus 2. I did that because I'm going to change my radical notation to exponential notation because I kind of noticed that the 8 and the 16, something was working in the back of my head there. And I noticed that I could just write that as 2 to the some exponent, 2 to some exponent. And they turned out to be perfect, a perfect match with my index, or indices, plural. All right, so let's keep going here. This one's going to stay the same. I'm going to have the cube root x plus 2. Nothing there. That's going to turn into 2 to the 3 over 3, which is just going to be 1. So I've effectively rationalized my denominator. Let's just try over here. So here I'm going to have 2 to the 4 over 4, and down here I have that. Pretty good so far. So let me just rewrite this as 2 times 2 to the 4 over 4 is just 2 to the first. So 2 times the cube root of x plus 2 over, down here, 2 times the fourth root of x plus 2. That makes things look pretty easy, actually. Now I can factor out a 1 or cancel it out. I hate to say cancel it out because I'm not really canceling it. I'm just rewriting it as 1. And this over here I'm going to rewrite as x plus 2 to the 1/3. I can just assume that there's like a parentheses there, and that's just raised to the first power. So I'm just going to say x plus 2 to the 1/3. And down here I'm going to have x plus 2 to the 1/4. You might remember your rules of exponents at this point. Remember, when the bases are the same, what can I do to those exponents? I can subtract them when I'm dividing. When it's in a division problem, I can subtract those exponents, as long as the base is the same. So, in my sixth step, I'm going to write this. X plus 2 to the 1/3 minus 1/4. I can do that because, again, my bases are the same. Now, to subtract 1/3 minus 1/4, I need to get a common denominator. So I'm going to multiply, the common denominator here is 12. So I'm going to multiply this by 3 over 3. I'm going to multiply this fraction by 4 over 4. When I do that, remember, multiplying by 1 doesn't change anything, but it certainly can change the appearance, even though the quantity remains the same. So I am now going to have, just leave my base alone, 4 over 12 minus 3 over 12, which is going to be 1 over 12. Eighth step, x plus 2 to the 1 over 12. Now in my class, remember, I don't like to leave fractional exponents. I say if it's a fraction that's less than 1, go ahead and put it back under the radical sign. And that's what we're going to do here. So my final step, and remember that's exponent over the index. So the index is going to be 12, and it's going to be x plus 2 raised to the first power. I don't have to leave that. So that's going to be my final answer, the 12th root of the quantity x plus 2. So let's look and recap what we just did. From the top, if I'm multiplying two radicals that have a different index, one of the things I can do is start working on them individually. So I did that. I broke them up here into two individual radicals in a division problem. Same thing here. I ended up being able to reduce a portion of that using my laws of exponents. 2 to the 4 over 4, 2 to the 3 over 3. When I rewrote this whole top part, it was just 2 times this quantity, 2 times this quantity. Reduced that. Took the remaining radicals, changed them to exponential notation. Again, used my laws of exponents to subtract the exponents. Converted the fractions to a common denominator. Subtracted the numerators like you can do with fractions. And then rewrote this because I noticed that my fraction was less than 1. So I rewrote it back in radical notation. These are actually kind of fun. You just have to pay attention to what you're doing. Break down the problem into simpler problems. Are there other ways to do this? Absolutely. Are there faster ways to do this? Absolutely. I don't mind whatever you choose, just as long as you can justify what you did by using good math and using the good application of the rules that we have learned so far. This is like writing a paragraph. So write your own paragraph for me, and good luck on the next problem.